So let us learn about the character data type in C programming language. So character is essentially a 1 byte integer where every integer is mapped to its the host machine's local character set. So as we have already discussed about this, that these are the few basic data types in the C programming language. So if you observe this char, so this char data type represents a single byte, and in single byte we are having 8 bits. That means we can represent 8 bit of information in a single byte. So this is capable of holding one character in the local character set. That means on your host machine, whatever is the local character set, so based on that it will be holding single byte integer corresponding to that character. So again, this integer is something that we have already discussed. So this naturally in most of the 64-bit systems, it takes 32 bits, that is 4 bytes. And we are having size specifier such as short integer that takes 2 byte, integer itself takes 4 byte, and long integer takes, that is 8 bytes in 64-bit systems. Now real numbers we'll be discussing later. Now if I talk about the character types, so the basic char is definitely a basic data type. So the values of char can vary from one computer system to other, because in different machines can have different character sets, right? For example, one of the most commonly used character set is ASCII, that is American Standard Code for Information Interchange. So typically it is a 7-bit code. That means the 8th bit is not used, right? So it is a 7-bit code, and in 7-bit, if I talk about, the smallest integer that we can represent in 7-bit will be 0, and the largest integer that we can represent using 7-bit is 2 to the power 7 minus 1. So total 128 characters, right? So in ASCII, this digit 0 to 9 are represented by this code respectively, right? So the ASCII value in decimal for 0 is 48, and for 9 you can just add the remaining numbers, right? For uppercase A it is 65, and this one you can observe for the decimal 65, decimal integer 65, this is the binary representation, and similarly you are having the binary representation for this uppercase Z. So ASCII is often extended to Unicode again in further machines, but anyways, with regard to C programming language, we will be talking about ASCII character set itself. Now if you observe this char ch, so ch is the identifier, this is depicting the variable name, and the data type is character, and this is how the characters are stored. So character literals are always represented within single quote. So you can observe here lowercase a, uppercase a, the digit 0 and the space, right? So character constants are enclosed always within single quote and not double quote. So let us write some code with regard to this. Now let's say if I'm writing char ch assignment, let's say uppercase a. So if I just print this one, let's say printf percentage %d, and I'll give a slash in here, I'll write ch. So this will print this, actually this character a which you're observing, it is stored in 1 byte. So in 1 byte it is stored the binary of this a that is stored. So binary of a cannot be stored directly. The corresponding value for this character a in ASCII set is 65. So whatever is the binary representation of 65, that is stored in the memory of 1 byte actually. So if I print this one, so if I compile and execute this, so you can see it prints 65. If I want to print the character itself, I'll be writing here percentage %c. Now if I compile and execute again, so you can observe the output for line number 8 corresponds to 65, you can observe, and the output for this line number 9, since I have used the format specifier as percentage %c, hence it prints a. If I write the space character, let's say I'm writing space over here, if I compile and execute, so for space it is 32, and since the space character is not visible, so you can observe space is also printed indeed, right? Similarly, if I take the character 0, compile and execute, so here the ASCII value for character 0 is 48, but make sure there is a small catch here. If somebody writes 0 like this, we can definitely store 1 byte integer within character type. Now if I compile and execute, the value is also 0, and the character corresponding to this 0 in the ASCII table is null character. So for null character we cannot print anything. For example, how printf uses null character is that printf treats, let's say if I'm writing abcd, or let's say 1 2 3 4, and if I'm writing null character, let's say slash 0, and then I'm writing 6 7 8. So what printf does is, so generally the C programming language, it considers, let's say I'm writing ABC A678, it considers this slash 0 as null character, and this acts as the string terminator. So if I compile and execute, you will observe the output that only, okay, semicolon was missing here, let me just add it once, compile and execute. So you can observe here that after the space 1 2 3 4 is printed, but after 1 2 3 4 this A678 is not printed. That means printf treats null character as string terminator. Anyways, we deviated little from our character discussion, but still. So I repeat again, this char, even though you're representing character, so this is a character literal which visually appears to be a, but internally it is 65. That is the ASCII value of a, and 65 in turn is stored in its binary form. That is this particular binary pattern, as you can observe here, right? This is the pattern. So it depends that what format specifier you are using, because end of the day in my memory in 8 bits my a appears as this, right? So when you are using this percentage %c, it goes to the table and checks for that given number what is the corresponding character, and hence it is printed. For example, if I write lowercase a, so the ASCII value is 97, right, and so on. So character is available in two forms, that is signed and unsigned. Now, so the C, in C programming language, the character type, it is designed to hold a ASCII character and should be used when you're dealing with characters, right? So this char data type can be signed. So for signed, the range is -128 to +128. And as we know that the integers are stored using 2's complement form. And let me remind you, the non-negative integers are stored in direct binary form, but when we talk about the negative integers, its 2's complement form is represented. But when it comes to unsigned, so if I can compute, we know how to compute the range of unsigned, that is 0 to 2 power k minus 1, where k is the number of bits. So here 8 bits is there, so within 8 bits the smallest integer that we can represent is 0, and the largest integer that we can represent is 2 to the power 8 minus 1. So 2 power 8 is 256, and 256 minus 1 is 255, right? So that's the range of unsigned. But in case of signed, we use the range of 2's complement form. So if before this char, if I am not mentioning the word signed here, so by default it remains signed. So for example, let's say if I write a, let's say 127, so this is the largest value that this char can hold, right? So if I compile and execute this one, so it prints 127, right? But if I write 128, so guess, you think about the output for this one, compile and execute. So you can observe that it overflows. So if you can consider a number line where you have 0 to 10 as the number, so if you go after 10 you will fall back to 0, and if you go before 0 you will fall back to 10. So when you fall from largest value to smallest value, this is called overflow. So in this case, if I consider this one as variable a, so this went through overflow actually, right? But if I take the next variable, so let me show the maximum ranges first of all. 127 is the max, and for signed char b, and even if you do not write signed, it is by default considered as signed. And for this, if I write, let's say -128, so this is the minimum value, right? So I'll just print this one. So you can observe this is the minimum value. So let me compile and execute. So you can see maximum value and minimum value is printed. Now, if I write a assignment, let's say 128, so 127 will overflow to -128, and if I write b assignment, let's say -129, right? So if you try to go behind this -128, you will fall to this 127, right? So let me print this 2 again. So let me compile and execute. So you can observe here overflow warning we are getting. So you can see for the first two output, that is 127 as the max value and -128 as minimum value for character data type, this is depicted. But if you observe this for this a 128, right? So when you try to go outside 127, you fall off to -128 like a number line, right? So it's like a clock, like after 12 you go to 1, and before 1 you fall back to 12, something like that. And for this -129, so when you try to go behind this -128, now there is no smaller number that is possible to be that can be represented within 8 bits. So -128 again falls back to when you go one step back, you fall down to 127. So this is called underflow, right? So that's the idea of signed characters. Now similarly, I can use unsigned. So in unsigned, the maximum value that I can represent is 255, and the smallest value, smallest integer can is 0. I'll comment this out for a while, and let me compile and execute this. So you can observe the max and min value. The very same thing if I do it here. Let's say after 255, if I try to go to 256, so it will fall down to 0. And if I try to go behind 0, that is -1, behind 0. I'm trying to go behind 0, right? Let me compile and execute. So you can observe here 255 and 0 is the max and min value respectively. But this is pretty interesting that when you try to go after 255, you fall back to 0. And for this -1, it is not falling back, because the reason is that in integer, in signed integer, it is possible that you can represent this. Actually, what is happening, this percentage d is printing in its signed form, right? So better to use this percentage u. Let's use this and print these numbers, right? Now let me just compile and execute, and you can observe here. So this prints a very large number, right? You might be thinking that why it is not printing 256. Actually, it is reading all the 32 bits, right? So in 32 bits, whatever binary representation is there for -1, if you convert that into that is the decimal form, then you will get this large integer, because it is reading all the 32 bytes for this -1, right? So that's the idea, right? Yes. So I hope this signed char and this unsigned char is clear. And moreover, in this char, in this char b assignment 0, I haven't applied the unsigned one, right? So that might be again one reason. So let me apply unsigned. So that was whatever we observed, that was for signed actually. Now let me go for the unsigned one. So let me compile and execute again. And now you can observe. So last time it was very large integer, because that -1 was treated like 32-bit integer, right? So that's why when that -1 was interpreted uh, using 32 bits, so we are getting very large number. Now since we are using unsigned character, so from -1, when you so 0 is the minimum value that is possible in unsigned, right? So now before 0 there is no smaller integer. So if you fall back from 0, you will fall to 255. So like if you consider clock, in clock the max value is 12 and min value is 1. So if you go after 12, you will fall to 1, and if you go before 1, you will fall back to 12. So that's the idea of overflow and underflow respectively. So when from larger value, from the max value you fall to minimum, this is overflow, and when from minimum value you fall back to max value, this is called underflow. So that's the idea. In the concept of data type conversion, we will be discussing about this in more detail, but I hope we got a clarity regarding signed character and unsigned character. So whenever, so it's a very good suggestion that whenever you need to deal with 1 byte integer, whenever we need to deal with 1 byte integer, it's always recommended that you can use the char type, because end of the day the character is integer, right? It stores the data in single byte. So in single byte, what bits are stored and how do you represent, how do you interpret those bits using the format specifier, that matters end of the day, right? So that's about character data type.